So here's another circuit simulation for you. We've got a loop of current, kind of like what we've had previously, but this time that loop has these two large blue plates in the middle. And it's this type of setup that you would use to create a capacitor. Capacitors are used to store charge. Basically, you deplete the charge from one plate and add it to the other plate so that you can store an electrical potential energy between the two plates. So we've set up these branches of the circuit just like usual. I've got 5 wires set up here where it says make circuit loop. And basically we've got the directions going around so that the current flows from the right side of the circuit over to the left side of the circuit. And of course we've adjusted the voltage across each one as usual. And then we have the 2 plates down here. So they're a little bit different in that when you get to their size, we've swapped the length and width of them so that they are very wide but very short. So if you zoom in on these plates here, you can see that there's electrons bouncing around inside, but they don't really have anywhere to go except out through this wire here. So the vast majority of the electrons in this plate that are bouncing against the wall on this side can't get out, so they're kind of being throttled by the relatively small size of the wire here. On the other hand, over here we have the opposite effect. We've got electrons being deposited into the plate from the wire, and then once they're in, they have a very difficult time getting out, because even in the off chance that they get over into this wire, the electric field is pushing them back into the plate. So if you watch this for long enough, what you can see is that the number of electrons in the right plate is going to decrease, and the number of electrons in the left plate is going to increase. And that's, of course, going to create an electric field in between here, or at least in real life it creates an electric field. I haven't set up an electric field in the code yet. But basically you have negative charge building up here, a net positive charge building up over here by depleting the negative charges, and so electric fields go from the negative side to the positive side. So you could draw in an electric field going from the left plate to the right plate. Now you notice there's not a whole lot of current going on in the loop anymore. Again, that's because our flow of electrons is being strained by the relative size of the plates and the wire. So we don't have a whole lot of current going on the red wire. And in fact, if you watch the current in the graph here, the current in these wires is decreasing. That's something you can watch for, is the graph of current versus time in a circuit involving a capacitor. Notice that we're only graphing the current through the wires, not the current through the plates. It doesn't really make a whole lot of sense to look at current through the plates. And so to enforce that, I've added on one more variable to give as an argument for this make wire function. And that's just this do graph variable. So if do graph is true, then yes, we do make a graph. If it's false, then no, we do not make a graph. And so we're only getting graphs for the wires, and they're matching up pretty well as can be expected for this rough simulation. So this is a great way to help visualize how capacitors work, or how RC circuits work. So in the problems that'll follow, you can play around with the size of this capacitor to change its capacitance. You can change the resistance in the circuit to change see how that changes the charging. And basically what you want to look for is how quickly the current in this graph depletes. You can also probably find a way to calculate the charge in each of these plates by counting the difference in the number of electrons in each of the plates. So I hope this is useful to you as you are studying RC circuits, and I hope it helps you learn a little bit more about how they work. Thanks so much for watching. I'll see you next time. Bye-bye.